Hello. Um, Today I'm going to talk about infrastructure as .NET code using Pulumi. Um, my name is James Murphy. My job title is Cloud Software Engineer. I first put my hands on a keyboard in 1979, and I've been writing code and learning new things ever since, which is something over 4 decades, which is frankly terrifying. So Pulumi, what is Pulumi? Pulumi is a tool for defining infrastructure as code, actual source code, C# and .NET and TypeScript and things like that. It's also a tool and a service for managing deployment of that infrastructure. That definition raises a few questions. What is infrastructure as code? Why is it a good idea? And if it is a good idea, why Pulumi? So let me ask a different question. What is it that we do? At the most basic level, as a software engineer, we find problems and deliver solutions to those problems. In my case, those solutions are deployed to and take advantages of the services provided by public clouds, for example, AWS or Azure or GCP or Ali Cloud, quite possibly. So we have a definition of delivering value that says we need a deployed solution available to our users. To be effective in delivering, we can take guidance from the experience of others. And Accelerate by Dr. Nicole Forsgren and all, we have clear evidence that the time to go from committed code to deployed application correlates very strongly with high-performing teams. This leads us to continuous delivery by Jez Hunwell and Dave Farley. And the principles in that are that we build and package once, and we deploy to multiple environments as needed, but that we always deploy in the same way, whether it be to the dev environment or to staging or to production. I could talk about this all day and will happily do so over cold refreshing beverages. But a key principle in continuous delivery is that we automate everything. We automate things to make them trivially repeatable. And that has to include deployment. So if we wanted to automate everything, then using a cloud web console isn't the answer. So how do we automate the definition of infrastructure or the definition of deployed systems? And there is a considerable overlap between the two. There are a couple of approaches. We can script things. All of the cloud providers provide REST APIs and command line tools to create and configure services. Unfortunately, we want our definitions to be idempotent. We want to safely be able to run the same script over and over again, whether the services exist or not. And that gets quite difficult really rather quickly. But there's another approach. Better, we want to take the Picard approach to define what our infrastructure should look like and then tell someone else to make it so. This is known as desired state configuration. The good news is that the public cloud providers support this approach. They have declarative systems for specifying your requirements and engines that magically transform those specifications into cloud infrastructure. The bad news is that we very quickly end up with a wall of markup, be that JSON or YAML. This is the start of the ARM template for my sample system. It's over 300 lines long. The equivalent in CloudFormation YAML would be of a similar size. The problem with these templates is that they are hard to read and therefore hard to maintain. There is a huge amount of duplicated boilerplate and not a small amount of arcane cleverness where programming concepts are brute forced into markup to overcome the limitations of straight JSON or YAML. So the templates require you to understand not only the infrastructure you're targeting, but also effectively a whole new language used to create and configure that infrastructure. Coming back to our core problem, delivering value by making deployed solutions available. There is a strong argument outlined in the excellent team topologies that delivery teams, say 5 to 9 people, should own solutions end to end. That is to say, you write it, then you should deploy it, and then you should operate it. It all belongs to you. A key limiting factor on what an individual team can own and operate is how much cognitive load it can support, what it can comfortably think about. Having to understand ARM or CloudFormation or the YAML for Google's Cloud Deployment Manager will consume a goodly chunk of that available load. So we want something that is both more flexible than JSON or YAML, and that is more easily understood by the developers on a delivery team. In other words, source code. Clearly, this is a good idea. AWS are working on providing the CDK, which is the Cloud Development Kit, which is a cross-platform way of expressing CloudFormation. For Azure, there is the very impressive Farmer. It's an F# DSL. I'm bound to like it. And Microsoft are experimenting with Bicep. Or there is Pulumi, which targets multiple services and which lets you write code in Python, Go, and in languages that support Node.js and .NET. And that means it's probable that your team can define the system it wants to deploy using something it already understands, and remove some of the additional load, leaving more space to think about the actual problems rather than how just to shave yaks. The other advantage we gain from having infrastructure defined as code in text files, whatever format, is that we can store that infrastructure with our application source code, and that we can see it evolve and can audit it in the same way we do all our source code, and that we can revert changes in much the same way, in theory at least. At this point, it's clear that defining our infrastructure in a text file is a good thing. It makes things repeatable, it makes it possible to deploy to multiple environments, as we want, when we want, and we can version control, which gives us a history and the ability to audit and control what we do. On top of this, Pulumi gives us a degree of language independence, a system for managing deployment, and a degree of target platform independence. It supports the core providers that we've come to know and love, but it also supports more cloud providers, all kinds of infrastructure, and the list just goes on. So I want to use Pulumi for everything. If you think about this in the context of onboarding a developer and the access and privileges they need, the ability to add a very small amount of things to a source file and have all of their requirements met is really quite compelling. That's probably enough why. I've whittled on without showing you anything interesting for quite long enough. I could fill the rest of my time just talking, but I did promise some source code, so let's have some how. Imagine an application something like this. We make a request to a service. The service looks to see in some storage to determine whether it's already got the answer to the question. If it hasn't, it goes out to a third-party service, pulls the appropriate data, transforms it into an internal reference format, saves that out to the same data store, and then returns the result. For this example, I'm going to use an Azure function for the service. That will be an AWS Lambda function. In Azure, I'll use a blob. In AWS, I'll use S3. One would more probably use something like Redis for the storage, and one would probably expire the values over time. This is a very simplified version of real systems that I've worked on over the past few years. So how do we start? Pulumi operates from the command line, so we can install using the appropriate tools for your preferred dev platform. It runs on Windows and Mac and Linux. Once we've installed it, we work from the command line. So here is a new empty folder. I've just done a git init and stuck a global JSON in so that we force it to be .NET 3.1. I'm going to make a new folder for my Pulumi project. I'm running Pulumi version 2.10 here, so that proves that it works. Pulumi needs to store its data somewhere. We can store it locally, which would store it in the root, the user home directory off the user root. But for this demo, I'm going to store it in a file relative to the Pulumi folder, so I'm going to store it just below that. I'm going to create a new Azure C# Pulumi project, and this will walk through creating both the project, which is a project for demonstrating Pulumi, and the first stack. So a project is a group of stacks. A stack is both a thing you can deploy multiple times, and also you can have multiple different stacks for deploying different things. Because I'm in Azure, I want to run the UK South. When I've created it, it will build the project for the first time, and there we are, ready to go. We need to remember have a secret to protect. We need to have a passphrase to protect our secrets. The easiest way to do it is to have a passphrase. There are other better ways that are strung more securely. Using the Pulumi backend service is one of those. So at this point, you can see that I've run a preview, and the stack wants to create a stack, and it wants to create a resource group in that stack and some storage. Because I want to run multiple stacks, I want to remember where I want to deploy to. So I'm going to have one stack for dev. So I'm going to set a piece of config to deploy to dev, and what I'm showing you there is the config file for the Azure Dev stack. And then the second one, I want to create an Azure test stack. It again wants its own passphrase, although I've used the same one because that makes my life easy. I'm going to set the same config as deploy to test. And then because I want to work with the dev stack, I'm going to select the dev stack again. Okay, cool. So what does this code look like? It looks pretty much like an Azure console app, to be honest. Azure .NET console app. Our entry point is a program. We are running a static method on deployment, which will do magic. And the class invokes is the bit that's most interesting to us. This is the templated stack that was created for us. Going top down, we have a resource group to group things together. We create a storage account in the same resource group. And finally, we select the connection string for the storage group as an output. In each of these, we're giving it a name, but this is the name that Pulumi uses, and we'll see that in a minute. And there is a general pattern that these follows, where we have a new something, a new account in this case, it has a name storage, and then it has some arguments. The things that we export can be used by other stacks, so we can chain stacks together. However, I want to make a few changes before I deploy this. I want to rename it because my stack is not really very useful and meaningful. In context of this, I'm going to do an Azure stack and an AWS stack, so we'll call this the Azure stack. First thing we're going to do is to read the deploy to out of the configuration that we created. We're then going to name the resource group a bit more usefully, and we're going to include the deploy to in the name to help the programmer when they're looking at things in the console. I'm also going to explicitly name the resource group in this case, because that makes my life easier later on. By default, Pulumi will add a random string to the end of every name, an 8-character random string to the end of every name. This means you won't get collisions. This means that you could deploy multiple instances of a stack, or multiple stacks, but multiple instances of the same infrastructure without changing anything, because the names will automatically be different, so therefore they won't collide. But as a developer, I want to be able to have some clue as what resource group 1, 2, 3, 4, 5 actually applies to. Lastly, don't want to export the connection string because it's a secret, but I will export the account name. So now let's see what happens when we deploy this. I set up a new subscription in Azure for the purposes of running this demo. As you can see, there's nothing in it at the moment. So if we go back to here, I've saved my secret in an environment variable to stop having to type it every time. Same code, .pulumi folder, which is going to have the stack data in it. First of all, there are no existing resource groups. The first thing Pulumi is going to do is build everything and create a model of the resources it wants to deploy. It's going to check that against the existing resources, of which there are none. So we've got 3 to create. I've said yes, so now it's going to go off and it's actually going to start creating things in Azure. Resource group was easy. The storage counts takes slightly longer. And there we go. As you can see, the storage account name is the name that I gave it in the source code, NE-RPC demo dev, and then with an 8-digit number appended on the end. I list the groups, the resource groups now, you'll see that there is one resource group. And if I list resources in general, you see that we have the storage account that was created as part of that. So it lives. Hooray. This is a screenshot of the resource groups after we've run that deployment. The important one of the reasons that the Pulumi gives you is able to do what it does is it stores what it thinks the world looks like as you run through the service. So it's created a large file full of JSON that defines not only it defines the state as it thinks the world should be at the moment. So if we take a look at, this is the Azure Dev Stack. And if we take a look at this, this is the resource group we created. The interesting thing in here is we have, there's the project name, there's the stack name, there's the project name. We've created a resource group. This is the name of the resource group that we gave it in our source code. And then this is an ID from Azure telling us what resource has been created that goes with that Pulumi unique identifier. If we go and look at the storage account, there's the name that I gave it, NE-RPC demo dev, but the subscription that's actually, the storage account that's actually been created has the number appended to the end. This prevents collisions between resources. I'm not entirely happy with that, but it's a valid approach and worthwhile. This file is huge. It gets updated every time you change things, and it's how Pulumi keeps track of the world. That doesn't do anything particularly useful. So we want to add the function and the containers necessary to do something a bit more useful. One of the things is that the function itself isn't really very important. Function code isn't very important. But what does matter is that we need to configure it for each environment it runs in. So this is the source code for my function that I'm going to deploy. Doesn't really matter what it is, except but it is in the repository, and the repository is available on GitHub. The important thing here is that we have some configuration. We need a host, and we need a connection string, and we need a container, and that we read those values using the standard .NET Core configuration system from environment variables. So that's a standard Azure function. I've done a .NET publish in that project in the functions folder, and I have a folder sitting in there with it in. So the first thing we want to do is we want to add some resources to our existing stack. We're going to add 2 containers. First one is to contain the zipped up package code, and so that will actually run. And then the second one is the data container that we're going to use to cache our values as we go through. The next thing we need is an app service plan. The app service plan is sort of the container that we run our function apps in, our functions in. Tier dynamic size Y1 means it's a consumption plan. So now what we're going to do is we're going to take the publish folder, and we're going to stick it in a zip file. We're going to upload that zip file into blob in Azure Storage. We've pulled the storage account name from the storage account we created, and we've pulled the container name from the storage we created. Then we're going to get a access signature for that blob, so that we can then create the function and pass that code blob URL into the configuration for the function. So the function has a resource group which we created before, app service plan ID which we created before, a whole load of settings, storage account, storage access key, and we want to run version 3 of functions. Note here that we've put the configuration that my function needs into it. So the quote server host is where it can go and get some data from. The data connection string is the primary blob connection thing for the storage account we created earlier, and the data container uses the container name. Lastly, we're going to output the endpoint so that we can actually make a call to the function. So let's deploy that and run it. I love the way it jumps down there like that. Artifact of the thingy. Right. So I'm going to do Pulumi Up again. Again, it's going to build the project. It's creating a model of how it wants the world to be. It's comparing it to how the world is. And now it needs to create 5 new things. The plan, the 2 containers, the blob that holds the application code, and the function itself. Because I've said yes, it's off performing the update. You can see that it will run things in parallel where it can, and it will run them sequentially where it can't. It's smart enough to work out dependencies for you. If you need to, you can be explicit about the dependencies and make sure that sequencing works exactly the way it should. And here we have the watch the kettle problem. So I shall This is the point in the demo normally where things go wrong. Because I've recorded this, I know that things went well. But it still always takes longer than you think. There we go. So at this point, I've created all of my functions. Now we've got 3 resources, it says, rather than just the one we had before. And what I can do is I can make a request to that URL, and I get a Douglas Adams quote. If I change the body to be a different quote, I get a different Douglas Adams quote. The requests, just so as you can see, are a little bit of JSON. So now that's my Azure dev stack. If I do Pulumi Up on Azure test, because the stack never existed before, it's going to attempt to create everything rather than just the new things that we had before. Because this takes a while, I will skip to the end. 1:35 to deploy all of that. Normally, of course, you'd bury this in your CI/CD system, so it wouldn't really be something you're sitting around waiting for. The last thing that we can see on that is that there are now 2 stacks, a dev stack, or 2 sets of resources rather, a dev set and a test set. So moving on. Here we have a screenshot of Azure before I delete that subscription any minute now. And we have the dev and we have the test. Okay, so I've deployed to Azure. How about deploying to AWS? I promised the same. This is the templated default stack for AWS. It's even less complicated than the Azure one. It creates a bucket, and that's about it. But since we know that every single AWS project must involve a set an S3 bucket, it's not a bad place to start. So let's add the code to create and deploy a Lambda. First thing we do is we're going to use Pulumi AWS rather than Pulumi Azure. I just completely lost my place there. Okay, I'm just rattling through the stack then. So let's change that to be an AWS stack. Exactly the same as for the Azure stack. We're going to pull in the config and the deployed to value from the YAML file. Because we don't yet have resource groups in the same way that we do in Azure, we're going to tag everything we do, or tag as much as we can do. I'm doing this on a per resource basis, but there are some nice hooks for doing it magically across all of the resources. Practically, we should be tagging our resources in Azure too. I just haven't got to that yet. So I'm going to create tags. They're going to be an input map, and they're going to be the user project, which is the Pulumi project name, and the user stack, which is the Pulumi deployment instance stack name. I'm going to create the S3 bucket, and I'm going to add bucket arguments, and the bucket arguments are going to include the tags. I've also done the same thing with the naming, and again, because S3 buckets have to be globally unique, I'm going to let Pulumi do the random addition on the end. Because we're playing in AWS land, we have to have roles and policies. These are hard, but this is the role that AWS requires to be able to run the Lambda at all. This is a policy that allows the Lambda function to write to CloudFormation logs. This is a bucket policy that allows the Lambda function to read and write from the S3 bucket that we've created. If we didn't do that, it would fail. The interesting thing here is this output format. Because these values don't exist yet, because they're created as part of the magic of creating this, we have to do a little bit of creative work around this to allow the values to be created and then injected into the resource later on. Yes, in exactly the same way as we created a zip for the Azure function, we do the same thing with the AWS Lambda. We do a .NET publish into a folder. We create a zip from that folder. We then again, in the same way that we have from Azure, we pass some environment variables into the Lambda. In this case, we just need the server host and the data bucket. That's part of creating the whole Lambda function. So we have a new Lambda function, .NET Core 3. It uses the file archive, as we've said. We have a handler. We have a role. We have to change the timeout. The default timeout is 3. That's not helpful. And we have some tags on the end. If we run Pulumi Up one more time, we want to deploy the AWS dev stack I created. Because normally we're going to want to run this in our continuous delivery pipeline, we want to run it non-interactive. Because we're running non-interactive, we need to say yes. So we're now doing exactly the same things. We're doing the build. We're working out what we need to create. We've got 6 that we need to create. And now we're going to run through, create those resources. I love the fact it says 6 to create and then creates about 8 things. Anyway, and we end up with a data bucket with a name, a function invoke ARN. And at the end of all of that, we now have 3 live stacks, AWS Dev, which we just deployed, Azure Dev, and Azure Test. Ideally, I'd have put an API gateway in front of that, but I had forgotten just how much fun putting an API gateway together is. I couldn't make that work. However, I can show you that we've deployed it and that I've passed in the environment variables, as I said, which are the uniquely named data bucket and the quote server host, which is the same quote server host that I was using for the Azure things. And then at the bottom, we've got the tags to say that it's the NE-RPC demo, and the stack is AWS Dev. And it does work, honest. There we have me running it and getting a quote example back. So there we have Pulumi deploying to two different cloud providers. The core business logic code is exactly the same. So I have 3 projects in my solution, and again, it's all in the repo. The presentation is the repo. The repo is the presentation. You can go and see it all. And only slight differences to run between the two. The details differ, but the process is very similar. So I've got one last example. This is real code, almost. The names have been changed. It's for Azure. It's in F# because I do all my work in F#. And it's getting a bit meta, but let's see where we are. So I'm creating the infrastructure that we use to run Pulumi and some other things. This stack is intended to create 2 different pieces of infrastructure, some DNS and the Pulumi infrastructure that we use. So I'm combining the output from 2 different sets of infrastructure, and the bit at the bottom where it says pipeline this into a dictionary is because for F# outputs are a dictionary. So looking at this, my DNS infrastructure says create a resource group called development DNS. I'm creating a DNS zone for the totally fake test domain. I'm creating a zone for that DNS name, and then I'm going to add some SendGrid domain validation stuff. And when I've done all of that, I'm going to output the name servers for the zone so that I can set them up with my registrar. The SendGrid domain validation says I need to set up CNAMEs for these 1, 2, 3 things. And this is the point where this being code starts to get nice. I'm going to take that list of parameters for CNAMEs, and for each one of those, I'm going to make a record. And the record says I want to make I'm going to have CNAME arguments, which is the resource group name, and the TTL and the zone name and all of that. I'm going to make a CNAME record from those. So I make a CNAME record, and it all just magically works. Then let's look at the next thing. I have a load of users, currently 4. It could be 40, could be 100. For each of those users, I need their object IDs. So I'm going to get the users, and then I'm going to map the object IDs from user results to inputs, and then I'm going to create an Azure AD group. I'm going to create the Azure AD group from the list of members that I got above. And it's as simple as that. That was something that made me really happy. However, to operate Pulumi in CI/CD, I need a service principal, basically not a real user. So to do that, I create a service principal. I have to make an application ID first, which I've forgotten. But I make a service principal, and then for that service principal, I allow the user to be, I then want to make the service principal a contributor so that it can actually make changes to my Azure resources. The other thing I need to do is I need to create a key vault to keep secrets in. Specifically, the key that we use to encrypt our Pulumi resources is in a key vault. To make that work, I need a list of permissions. The permissions needs to be a list of input and value, input and value, input and value. Typing input all the time is far too much like hard work. So we create a list and we map that list to input. So that list of list create get becomes input list, input create, input get, input update. I also need some secret permissions, same thing. We take those and we create a policy from them. From the policy, we can now create a key vault, and the key vault has a name, a resource group, the SKU, what we're going to charge it, who the tenant is, that's us, whether we allow soft delete, which we have to allow now, that's a requirement. And then the access policies are the input of the vault policy and the input of the service provider's vault policy. Finally, we create a key that we're going to use to encrypt our secrets in Pulumi, and yeah, enough already. Okay, that barely touches the surface of what's possible, but this is all code, and hopefully code that's straightforward to understand. And whether that code is in C# or F# or Python or Go or TypeScript, it's just source code, stuff that you already know how to read. So what have I missed? I haven't talked about secrets very much. You need to be able to keep track of secrets as because it's possible to pass values between stacks, and you don't want people to be able to read them. I haven't talked about having multiple stacks and passing outputs from one as inputs to another, which allows you to build larger, more complex systems with dependencies. I've barely touched on the notion of taking advantage of code to remove boilerplate and to enforce standards. I did mention that we could automatically tag things. We looked at the AWS policies, which are horrible, but they follow patterns, and it would certainly be reasonable to try and instead of having to write out large lumps of JSON in your source code, to write functions to provide you with the appropriate lumps of JSON. There was a shiny new automation API, too early in the day, shiny new automation API available, which is currently in Go, that allows you to write code to call Pulumi Up and the like, and allows for scenarios where you want to do things either before or afterwards that can't be done with the declarative process. There are some open questions, the most obvious of which is how to architect your stacks. I think people are still feeling their way with this one. Do you have one big stack for everything, but then you have a monolith, except you have a smart monolith, or do you have lots of interdependent stacks? And if you do, how do you avoid circular dependencies? This is not perfect. There are some potential issues. We do have to worry about updates to providers, about changes as the services evolve. Pulumi is built primarily on Terraform in the first instance. This has allowed them to have this huge breadth of coverage, this huge capability, without excess effort. But there are next-gen providers coming. The next-gen providers are native, and the first one of those is the Azure native provider. This went into beta on the Monday before I recorded this. The advantage of those is that they are much closer to metal. They reflect Azure's view of the world, or the cloud provider's view of the world. They're created automatically, and they will be up to date much faster. Pulumi are very good about getting updates out the door. Pulumi has ticked a couple of minor versions just in the time I've been preparing this. Pulumi is independent of the cloud providers. This is a good thing and it's a bad thing. The cloud providers want you to use them, so they are bound to encourage Pulumi, but at the same time, they're not part of the cloud provider, so you can take that one either way. The last problem is documentation. This is an impossible problem. The AWS CDK is the same. There's lots of details of what the methods are, what the parameters are, but it's much harder to produce sufficient prescriptive guidance on actually how you should do things. Resources. This presentation is on Gitpitch and on Git itself, GitHub. If you go to pulumi.com, all the world is there. If you go to Pulumi on GitHub, there are a lot of useful examples, and all of the Pulumi system is open source. Pulumi have a community Slack, which is excellent. If you are watching this before the 7th of October 2020, they are running a Cloud Engineering Summit. I'm on Twitter as recumbent. I have a blog, which hopefully when I've recovered from presenting this, will get updated with the stuff that I've gone. So finally, thank you for listening. If anyone survived this long, thank you for your attention. I've only been working with Pulumi for a couple of months and have much to learn, but I will answer any questions I can, and I'm planning on hanging around for the rest of the day if you're watching this on the day, if anyone wants to ask me about anything. Bye.